Hi class, Dr. G here. Today I wanted to talk a little bit about sampling error. It's a concept that we see in all of the research textbooks, applied research textbooks in particular. It's really a simple process to understand, but it's often difficult for students to make sense of it because of the way it's described. Today I'm going to describe it in a little different way that hopefully will give you a better understanding of the concept of sampling error. Let's say you had a population of 100 college students, and you wanted to get an average age for those college students. So you would take the college students, a list of college students, you would record their names, add all of those numbers up and take an average, and that would be your mean for the population. That is typically represented in the statistical processing mode by the Greek letter mu, mu, which looks like a strange lowercase u. Now let's say you decided to take a sample of those 100 students by using the nth number process, so that you would take every fifth student on the list and record those students' ages, and then add them up and take an average. And that average is called the sampling average, which is represented by X bar, and capital uppercase X with a bar on the top. The difference between the mu average, or the average for the population, and the sample average, the X bar average, will always be a little bit different. It's obvious because you used the entire population to get an average. When you took the sample, you may have left out some older people or younger people, and that's going to skew the average number. Now, let's say you decide you're going to do that sample again, but this time you're going to use the nth number of 2. In other words, now your population, your sample population, is going to be 50. 2 into 100 divided by 2 equals 50. And now you take the average of those 50 and get your X bar designation, your mean for the sample population. And now that sampling error is going to be smaller. The number is going to be closer to the mu number of the average of the population. And so the sampling error will be less. And that brings us to the fact that as our sample size increases in size closer to the size of the population, the sampling error naturally reduces. Now, if you decided to do that again, and this time you were going to take every 10th student in that list, your sample size is going to be a lot smaller. It's going to be a sample size of 10. Now your sampling error is going to be much larger, or larger, let's not say much. Now, if you put all of those 3 sampling distributions together on a page and look at them, that's called your sample distribution. And we'll talk a little bit about that in another video. I hope this helps you understand sampling error a little more clearly than you have in the past. Good luck. I'm looking forward to continuing to work with you.